Hi, today we're going to do lesson 7-6, the mid-segment theorem. This is the last lesson of chapter 7. Okay, so on this diagram, I'm going to correct it here and put 2 marks. I know D is the midpoint of segment AB, and I know that E is the midpoint of segment BC. So if you connect 2 midpoints, that is called a mid-segment. Okay, now we have to understand what a mid-segment is before we talk about the mid-segment theorem. This is theorem 37, and it says the mid-segment of a triangle is parallel to the third side and is half as long. Okay, so when you look at this picture, and I'm going to put 2 marks here, the third side, what it means is like this segment touches this left side and the right side. So the side that it doesn't intersect with is considered the third side. It is parallel to it, and it's half the length. Okay, so whenever you're using theorem 37, you can use it in 2 ways. You can use it to prove that these 2 sides are parallel, or you can prove that DE is half the length. So you could use it in either way. So whenever you have a question like this, it says find the perimeter. Now, I first have to tell you that you have mid-segments. So it's needed all these little markings. Okay, so now we know that technically we have 3 mid-segments here because D, E, and F are all midpoints, and you connect them. So these are 3 mid-segments. Now, this is actually pretty easy. You need to determine like what side is parallel to EF. Well, this side doesn't intersect with this side, so they're parallel, and it means this side is going to be twice as long, so it's 10. Now, I'm going to use 2 marks this time. It is parallel to this right side, and it means this is going to be twice as long, and otherwise known as the mid-segment is half the length, right? All right, and the last one. If the mid-segment is 6, let's put our 3 marks. It is parallel to segment AC, and I need to double it to make it 12. So for the perimeter, we're just going to add 10, 14, and 12 to get 36. Now, if no unit is provided, we know this is just the word units. And since it's perimeter, it's not squared or cubed or anything. So it's just 36 units. All right, so we're going to finish this chapter up with 2 proofs. Those proofs seem to be what hangs everyone up. All right, so let's go through this together. We have MDSO. So we have this trapezoid, and it is isosceles. So when it tells me it is isosceles, I need to apply that information. Well, I first know that this first step is given. If my pen will work there. Now, when I know I have an isosceles triangle, I know the definition. And the definition of an isosceles triangle is that the 2 sides are equal. So I'm going to go ahead and mark that. So I'm going to mark this side is equal to this side. Now, sometimes that's the next step, but it doesn't look like it is this time. So you have to make sure you always use your diagram. You can't just assume that's going to be the next step. They're talking on this next step about these diagonals. Now, it's important to know that it's isosceles when dealing with diagonals because something happens in particular when you have the diagonals of isosceles trapezoid. And this was our last lesson. Not today, is the one prior. So I have that pulled up here. All right. So let's look at this theorem. The diagonals of an isosceles trapezoid are equal. And that's exactly the situation that we have in this proof. Okay, so that is theorem 36. So we know these 2 diagonals are the same length. So I'm going to put 2 slashes and 2 slashes. AI is the mid-segment of triangle MDS. All right, let's find that on here. AI, let's change colors, is a mid-segment. Okay, so again, as soon as they tell me mid-segment, things pop into my head. First of all, let's find triangle MDS. MDS. So that is this big triangle. Now, I don't know what all we need because I haven't really looked further yet, but if it's the mid-segment, don't we know that it's in the middle? So we know these are equal. And what else do we know? We know that segment AI is going to be half the length of the side it's parallel to. So the side it's parallel to is MS. All right, and so how did I know step 3? Well, step 3 was up here and it was given. All right, it says AI equals 1/2 MS. Well, we just talked about that. AI, this middle segment, is half of the segment MS. All right, so how did we know that? All right, let's go back and look at some of our stuff from today. It's going to be the mid-segment theorem, right? Because it says the mid-segment of a triangle is half as long. All right, so this is going to be theorem 37, which is the mid-segment theorem. Okay, now the last step. I noticed that step 4 and step 5 are almost the same thing. They're taking out MS and replacing it with OD. Now, if I look up in step 2, I see that MS is equal to OD, so I can swap them out. And so what do we use when we're going to swap it out? You got it, substitution property. So when you're doing the proofs, always use the information they give you to get to the next step. Sometimes, you'll know more information than you need. Sometimes, you just have to mess around with it, and it's like a big puzzle. All right. We have one more to do, and we're done with chapter 7. A and E are the midpoints of the sides HY and YS of triangle HYS. Okay, so if these are the midpoints, that means that these are equal. Okay, so we're going to have to prove that HAES is a trapezoid. Okay. All right, first step, given. Yes. All right, so we need to prove that AE is the mid-segment. Well, how do we know that? Well, they tell you that A and E are midpoints. So this is just a mid-segment. Let's go back and look at the definition of a mid-segment. A mid-segment of a triangle is a line segment that connects the midpoints of its two sides. Okay, so since they tell you that these A and E are the midpoints, then AE is the mid-segment. Perfect. So definition of mid-segment. All right, so now we need to prove the AE and HS. Now we have to know what that symbol means. That means parallel. Now, if this is a mid-segment, don't we know a rule from today that proves that these two would be parallel to each other? That's the mid-segment theorem. And again, let's go back and look at it. The mid-segment theorem says the mid-segment of a triangle is parallel right here to the third side. And that's the part of the mid-segment theorem that we're going to use. So theorem 37, mid-segment theorem. Okay, now we're going to prove it's a trapezoid. Okay, so what is a trapezoid? Do we know? Now, I think I have the definition way up at the top. Sorry for all the scrolling, but it helps just to keep referring back to things that we know. Here's the definition. A trapezoid is a quadrilateral who has exactly one pair of parallel sides. Okay, one pair of parallel sides. Did we prove that already? We did. Right here it shows that they're parallel. So how can we prove that it's a trapezoid? Any ideas? It's going to be a definition. Definition of a trapezoid. Now we're not going to say it's isosceles because isosceles means the two sides are the same. And if we look back up at this picture, we can see that these two sides are not the same. We just know it's a trapezoid because these two lines are parallel. All right, guys, that is it. So the next class we are going to review. In the class after that, we will have our test. Please join the help session if you need any help at all. And see you soon.